Right, hi everybody, quick video here. We're going to go through surface area. We're going to talk about it from a higher perspective, but also a foundation perspective. Come up on both, so just make sure you know exactly what we're talking about. So first of all, if we understand what the concept of surface area is the area of each face added together. So let's look at this first example. We've got a cuboid here. So the thing that we need to know is that on a cuboid, we've got a front, we've got a back, and I'll draw this out in a second so you can see it. We've got a left-hand side, so imagine a shoebox. We've got a right-hand side, we've got a top, and we've got a bottom, okay? Now, you might have seen this done before where you talk about a net and you draw the net of the shape out, but the way I like to do it is think about blowing the shape up and then working out all the different bits added together. So if we think about it, the front of my shape there and the back of my shape there, which is, if we're talking about this bit here and then the back side there, they're my two bits that I'm looking at first of all. So the dimensions of that are 5 across, so it's 5 that way, and then look at the height is 4, so you'll be doing 5 times 4, which will be 20 centimeters squared. The front and the back are both the same, so that'll be 5 times 4 as 20 centimeters squared as well. So that's my first two bits to get in, the front and the back. They're both rectangles. And then if we think about the left and the right, now try and draw it so you can visualize it a little bit. That would be my left-hand side. That would be my right-hand side. And this is 10 centimeters that it goes back and 4 centimeters that it goes up. So if you think about this bit here, that's the 10, that's the 4 for my right-hand side. So that being 10, that being 4. So we go 10 times 4 to get 40 centimeters squared. 10 times 4 to get 40 centimeters squared. And then the last bit to think about is the top and the bottom. So I've got my front and back, I've got my left and right. I need a lid for my shoebox, which is the top. And then the bottom there is that bit. So again, looking at this, 5 is the width and it goes back by 10. So this would be 5 and 10. So for the bottom, sorry, I'm doing the bottom first. So 5 times 10 is 50 centimeters squared. And the top would obviously be 5 and 10 as well. Okay, so that's your first thing to do. That would normally get you a mark in an exam for thinking about working out the overall area of each face. And then because we know that we're just working every single area added together, all I do is just add all this together. It's quite a nice, easy one to work out. So I've got my two 50s make 100, my two 40s make 80, and my two 20s make 40. So you can just add those together. So that makes 180. 180 plus your 40 would be 220 centimeters squared. Okay, so you can think about it as just breaking down every single face and then eventually adding all of those together. Remember that your area, we're talking about area, so it's centimeters squared. Okay, so then if we just move that to the side there, let's now talk about how it's different with a cube. So think about what we know about a cube. We know that all faces are the same, okay? That's really important. If we think about that, effectively what we're talking about here is a dice. So think about a dice. The front face would be the same as the back face, which would be the same as the top, which would be the same as the bottom, which would be the same as the right, which would be the same as the left. So with a cube, what you can really think about is that effectively once you find the area of one face, you can then just multiply it by the 6 faces that it has. So it's a little bit easier. Now, the key thing is that I know that's 3. So that bit's 3, that bit's 3, and that bit's 3 centimeters. So the front is literally just going to be 3 times 3, which is 9 centimeters squared. And that's going to be exactly the same for all faces. And we know we've got 6 sides to this because it's a dice, remember? So you're just doing 9 times 6, which would be 54 centimeters squared. Okay, so with a cube, it's a lot easier. You just find the area of one face and then times it by 6. With a cuboid, just be careful to visualize it, break it down into its different shapes and split it apart, then add it all together at the end. So what happens if we have something like this purple question here? So now what you've got is you've been given the surface area. So it's a working backwards question. You've been given the surface area and then now it's saying to you, well, okay, find the volume. Now the volume's different because the volume is the space inside the shape, okay? So hopefully you understand how to find volume. If you don't, have a look at the other video I've done on volume, that will help you. But for a cube, if we're talking about volume, so if this was my cube, whatever that side is would be the same as that, which would be the same as that. You find the area of the front, so it would be the x, let's call it x times x. And then because it's then going back, you just times that by x. So whatever value you get here, you would times by that value and then times by that value. So that's how we're going to find volume, but the problem is we don't know what that is. So let's work backwards from what we already know. So it tells me that the surface area is 150 centimeters squared. Now we know it has 6 faces, and therefore 6 faces is equal to 150 centimeters squared. Right, well, I know that each face is the same, so therefore I can work backwards from that, and I can say one face I would divide by 6. So therefore I divide the 150 by 6, and 150 divided by 6 would give you 25 centimeters squared. So if I think about it, that's my front face, whatever, or side, top, bottom, doesn't matter. I know that the area of that is 25 centimeters squared. Well, if the area of that is 25 centimeters squared, and I know that this side is the same as this side, is the same as this side, is the same as this side, I'm saying that bit times that bit will equal 25 centimeters squared. Well, the number has to be the same, so effectively what you're doing is taking the square root of 25, which is 5. So in this example, what I'm saying is, in my cuboid, sorry, my cube, because it's all the same, every single face, we're taking the square root of 25 to get 5. So that's 5, and that's 5. And therefore, to find the volume, I just do 5 times by 5 times by 5, which would give me 125. And volume's different, centimeters cubed. Okay, so that's how you work with a reverse problem. Okay, I've got 2 questions here that you could have a go at then. So if you want to pause the video, have a go at trying to do these, see if you can get the answer to those, and then I'll give you the answer so you can double check you're working out. Okay, hopefully you've had a chance to have a go at it then. So if we're talking here about this first shape, we know that this is a cube. So that side, that side, that side, and that side are all the same. So find the front face. The front is just 4 times 4, which is 16. And then from there, I know that all faces are exactly the same. So I'm just doing 16. Remember, there are 6 faces, so 16 times 6. And then from there, you'll get an answer of 96 centimeters squared because it's surface area. So it'd be a mark for that, a mark for that. Okay, thinking about part B, looking at what we just did a second ago. So I know the 6 faces added together is equal to 216. So one face, I divide by 6. So you're doing your 216 divided by 6, which gives you 36. So I know the area of one face is 36. I've then got square root of 36. I get 6 centimeters. So thinking about what your shape would look like, that'd be 6, that'd be 6, that'd be 6. So your final answer is just to do 6 times by 6 times by 6. And you would also get an answer of 216 centimeters cubed. Okay, so in that answer, the surface area and the volume are exactly the same. That won't always be the case. Okay, so let's quickly look at a couple of harder examples now. So you can see here a bit different. It's now no longer a cube or a cuboid. What we actually have is a triangular prism. So the concept's the same, area of each face. We now need to think about, we've got a front, which is a triangle. So we need to think about how we find the area of the triangle, base times height divided by 2. And remember, the height is the perpendicular height. Okay, really important. The perpendicular height is this bit here. So for the front, I'd be doing 6 times by 8 divided by 2. So that's 48 divided by 2, which is 24 centimeters squared. So my front is 24 centimeters squared. My back is also going to be 24 centimeters squared. So that's that shape there and that shape there. Now I'm going to do my left-hand side, which if I think about it, would look like this. Okay, so it's this bit around the side here. That's 8 high, and it goes back by 10. So that's going to be 8 times 10, which is 80 centimeters squared. So I've got my 24 for my front, 24 for my back, 80 for the left. I now need to do my bottom. So the bottom part is under here. So it goes across like that, 6 and 10. So bottom which is 6 times 10, which is 60 centimetres squared. And the final bit that is the most confusing part about this is this part here. This I like to call the slope, okay, which looks like this. We've got 10 centimetres there, but the problem in this question is you are missing this side here, which is this bit on my triangle. This now involves you understanding if I've got a right angle triangle and that's 6 centimetres, that's 8 centimetres, how do I find that bit? And it's through using Pythagoras. So what you need to do is make sure you understand how to use Pythagoras for me, which is a squared plus b squared equals c squared, or if you just want to remember it as c squared, as square, add square root. For a longer side, so we'd go 6 squared, which is 36. We'd go 8 squared, 64. Add the two together to get 100. And don't forget to square root that 100 to get 10 there. So that side, that slope is 10 centimetres, which means that bit there is 10 centimetres. So I put my 10 centimetres there. So the slope, the area of the slope is 10 times by 10. So slope 10 times 10, which will give me 100 centimetres squared. Now in this instance, we don't have 6 faces. So in the cubes and the cuboids we just done, we had 6 faces. We now don't have 6 faces. We have 5 faces. So I've got my 24 for my front, 24 for my back, 80 for my left, 60 for my bottom, and 100 for my slope. So adding all those together, so make sure you just show that you're doing 100 plus 60 plus 20, plus 80 plus 24 plus 24. And when you work all of that out, you end up getting an answer of 288, and this will be centimetres squared, remember. So all your faces added together, you now only have 5 faces. 2 of them are triangles. Do not forget to do base times height divided by 2. If you are given a question where you've actually been given that side and you need to find that, for example, you're still going to use Pythagoras, but you're going to subtract instead of adding. So make sure you understand how to use Pythagoras. Okay, cool. Have a go at this one then. Pause the video, give it a go, see if you can figure it out, and then we'll go through the answer. So pause the video, have a go now. Okay, hopefully you've had a chance. So front, this time we're doing 12 times by 5 divided by 2. Remember to divide by 2, so that's 60 divided by 2, so 30 centimetres squared. That's my front. The back, same thing. So that's going to be your 12 times 5 divided by 2. So 60 divided by 2, 30 centimetres squared. So I've done my front, I've done my back. Now this time there isn't a left, it's this side. So I'm just going to call that the right-hand side, which would look like this. It's going to be 12 high and it goes 8 back. So you should have done 12 times 8 to get 96 centimetres squared. Then your bottom. So if we do the bottom part, which is that section there. So it's 5 across and 8 back. So that's 5 times 8, which gives you 40 centimetres squared. And the final bit here is the slope again. So just be really careful with your slope. Remember, you're going to need to use your Pythagoras. So this tall bit here is going to have to be found by doing 5 squared plus 12 squared. So 5 squared is 25. 12 squared is 144. Add those together, you get 169. And the square root of 169 is 13. So this value here is 13, which means I'm doing 8 times by 13. And when you do that for your slope, so 8 times 13, which is 104 centimetres squared. I've got my 5 faces, front and back, right-hand side now, bottom and slope. Make sure you're writing down the adding all of those together. So 30 plus 96 plus 40 plus 104 plus 40. And your final answer should be 300 centimetres squared. So your 30 plus your 30 plus your 96 plus your 40 plus your 104 gives you a total of 300 centimetres squared. Cool. Let's go through then this last style of question that you might get, and then I'll show you an example of a GCSE one that's come up in the past as well. So if we look at this, find the surface area of this triangular prism. So let's ignore that 12 for a minute. I'll show you how I got that, but imagine that wasn't there. So let's just get rid of that. So we still are going to go through our normal processes, front, back, left, bottom and slope, but we're just going to talk through each bit on what we do. So yes, I know that's 12, but how do I get 12? Well, I know that to find the area of the triangle, I've got to do base times height divided by 2. Okay, but the problem is that base, imagine that 12 is not there. Okay, so to get that 12, I've now got to do the 20 squared. So looking at that slope now, minus this 16 squared. Okay, so it's really important now, because in the previous examples we found that long slope there. This time we're finding a shorter side, so I need to subtract them. So I would have done 400 minus the 16 squared, which is 256, which gives me 144, and that's how I get my 12. So in this example, you're having to subtract. So now I can put that 12 in. 12 times 16 divided by 2 gives you 96. So that's the area of the front. That would also be the area of the back, remember. I can now look at my slope, my left-hand side, which is that 16 high there, and the 10 that goes back there, so that's the 160. The bottom, we know now that bit is 12, and that bit is 10, so that's 120. And the slope, which I could have done anyway, but that now is 20, and that bit there is 10. So you add all those together, you got your 200, plus your 120, plus your 160, plus your 96, plus your 96, and you get your answer of 672 centimetres squared. Okay, so the only difference in that one and the ones we've done up there is that you need to subtract this time when using Pythagoras instead of adding. Okay, last example. This one's pretty nasty, so you might want to pause the video here, have a go at trying to do this. What it's asking you for, so the shape is made from a cuboid, which is this bottom bit here, because it's 5, 5 and 6, and a cube on top, so the cube is all sides the same. Find the surface area of the shape. So what I mean by the surface area of the shape is the area of the front, right, the back, the left, the bottom, but be careful here because the top now is not the whole of the top. Part of that has been cut out, so you just got to think about what to do. So you might want to pause the video and have a go yourself. If not, I'm going to go through it now and you can check what you've done. So first of all, we know we've got the front of that bottom shape, so I'm going to do the bottom shape first. So 5 times 5 is 25. We know that's the same as the back. Okay, so the front and the back in this instance, same as always, are the same. The left-hand side is now the 5 times the 6 here. So that's that section there. That's all good, 5 times 6, which gives me my 30 centimetres squared. And the right-hand side is exactly the same, 5 times 6. So I've got my front, my back, my left and my right of this bottom shape. I can then do the bottom. The bottom is going to be 5 times 6 as well. Okay, it's not always that it will end up giving you the same as another side, but in this instance it does. And the top we need to be careful of. So the 5 times 6, imagine that bit isn't there. The 5 times 6 is still exactly the same as the top, but this time we're going to need to subtract the base of this top shape. So imagine I'm just cutting out this bit here. So I'm going to underline that and I'm going to come back to that in a second. So if we look at the top shape, we've got the front, we've got the back, we've got the left, we've got the right, we've got the top, we've got the bottom. It's a cuboid, so all sides, it's a cube, sorry, so all sides are the same. Now that purple bottom bit, we cannot see in this shape. It's not there. So I take that away from, so imagine that you've got the top of the bottom shape. That's that 5 by 6, this bit here. And I'm going to take away this 9 that I've got from the bottom of my top shape to give me 21. So effectively what I'm looking at is this bit round here, around the edge here, around the edge here, around the edge here. That would be my 21, okay? So the whole thing is now not 30, it becomes 21. Right, then you've just got to be careful what you add together. So I'm going to add together the front and the back of this shape. So there's my front, the pink bit at the back. Then I'm going to be adding my left and my right. So the green bit there, the green bit there. I'm going to be adding the bottom, which is the purple bit. But remember, I'm now not adding the whole of that top. I'm adding that bit round there, which becomes my 21. And then on the top shape, I'm adding my front, which is my 9, my back, which is my 9, my left, which is my 9, my right, which is my 9, and the top here, which is 9. But you are not now adding the bottom, so I'm only adding 5 faces there. And altogether, When you do that, you get an answer of 206 centimetres squared. Okay, so that's surface area. There are cylinders, there are cones, there are pyramids and things like that you can do surface area as well with. Slightly more complicated, different formulas, but I'll go through that in another video. But at the moment, that's your key things about surface area. Make sure you can do it in those ones. Hope that helped you. Hope you find it useful, and I'll see you all in the next video.